This is a maximum alert condition from potterblog.com. There's a high probability that a Japanese man was infected in Hawaii with coronavirus. This is a terrifying situation because it means summer weather infections are also highly probable. Here's the report. We'll have a link to this. The man was in Maui and Oahu. Our analysis and data is based off of this report on clinical characteristics of the 2019 novel coronavirus infection in China. There's a link to this in the end of our post. Basically, they tracked 1,099 patients to see what their incubation periods were. And it's important to note that our analysis is based on an extremely conservative uniform data fit of the COVID-19 coronavirus and incubation data taken from these 1,099 infected Chinese patients. They reported as having a 3-day median and 0 to 24-day range. Our analysis shows that there's a 52% probability the Japanese man acquired his infection in Oahu, Hawaii. That was actually the second place he visited for the shortest time. And that was approximately a 5-day visit. We have to read it here off the 4-day line because we start at day 0. Many of these patients reported 0-day incubation. So at day 4, we see that there's a 52% probability that he was infected there. There's a 57% probability the Japanese man acquired his infection in Maui. That's the first place he visited. He was there for 7 days. So if we look up here at the 6-day line, and we come out right at the 57-day part. Overall, there is a 67% probability that his infection was acquired in Hawaii. So if we look at that, that is right here at 11 accumulated days. Again, we read from the 10 mark because we start at day 0. So in the most conservative possible reading and data fit of this data, there's a 67% probability that this Japanese man acquired his infection in Hawaii. So this is our discussion of the situation. Using a uniform distribution of infection on either side of the reported day 3 median incubation period is an extremely conservative approach, and we'll get into that further later. We did this conservative approach to establish a minimum boundary condition. A less conservative, or likely more accurate approach would have used a left-skewed distribution with a high degree of kurtosis around the 3-day mark and a long tail stretched out to 24 days. Again, we'll discuss that later. We expect that a more accurate curve fit would indicate a 90% plus probability that the Japanese tourist was infected in Hawaii. Now, it's terrifying that this infection was able to occur in summer weather, as this indicates that this outbreak will continue and worsen throughout summer. All of CDC's planning up to this point has been based on the assumption that once flu season is over, that this coronavirus will calm down until next fall. Further confirmation of transmission in Hawaii or in summer weather locations like Australia and Indonesia would require the highest levels of risk mitigation. Now, this is extremely important. Confirmation of summer weather transmission would be a strong indicator that this virus was weaponized. But that doesn't necessarily mean that weaponization was done nefariously. Optimistically, weaponization would have been carried out for the sole purpose of making it easy and cost-effective to infect laboratory animals under humane temperature and humidity conditions. Yeah, it's a facility you want to operate inexpensively, and you want to test these lab animals under the conditions of wet markets in China. Now, source data and links are at the bottom of this post. We've also included links to all the purchases we made to risk mitigate this outbreak. So these are things that we've done, but these are not things we're recommending that you do. We're just letting you know what we've done. You need to make your own risk mitigation plan. But now on to the details of this analysis. The key here is we used a uniform data fit. In essence, a lot of people have misread what this study did, saying that the infections were possible out to 24 days. When it says it has a median of 3 days, basically that means 50% of the cases occurred prior 3 days and before. So approximately 550 people in China reported that their incubation period was from 0 to 3 days. The other 549 people reported that their incubation period was from between 4 days and 24 days. Now, what we've done here is make the assumption that these 550 people in 3 days were spread out uniformly, that you had the same probability of getting incubated on day 0, day 1, day 2, day 3, and that these other 550 people who caught it after day 4 through 24 also had a uniform capability of being infected. So obviously, most of the people get infected up front here during this early part. A more realistic curve, though, would show a really high peak occurring somewhere around this 3-day period, and then a very small, tiny link going out here to 24 days. Realistically, these people are reporting based on their memory when they think when they caught the virus, and that's going to be skewed towards earlier memories. Some people might have difficulty coming up with any sort of correlation, so they may stretch out way to this 24-day period, trying to find somebody that they might have caught it from that is a known infection point. But reality is almost all the data is probably in here in this 3 to 4 to 5 day range. And that's why a more realistic look at this data would probably put a 90% probability that this Japanese man was infected in Hawaii. And we may actually do that stat fit to see what that curve looks like and what their actual probabilities are. But given that the report states only 3-day mean with a 24-day range, the most conservative analysis we can do is this uniform distribution. And that's what we went with. And even with that uniform distribution, there's a 67% probability that this Japanese man was infected in Hawaii. So we need to keep our eyes on Hawaii, Indonesia, Australia to see if there's any more reports of person-to-person transmission, because that will be very, very, very bad. Pray for the best.